In the last video, we have created a basic GDExtension project. And so far, we have made a simple GDExtension class. Now in this video, I'm going to show you how to further configure your GDExtension project. So what I want to do in this video is to add a compile option. When I enable this compile option, a text label with an FPS counter will appear in the main window. Then by disabling this option and compiling again and running the project, the FPS counter will be disappear. By disabling this option, not only will the FPS counter disappear, but the code that adds the FPS counter will also not be compiled. This means the final library will be smaller in size. The reason I'm focusing more on the project setup right now instead of jumping in straight into the GDExtension coding is because this part is really important. Even I, after watching many C++ tutorials, I often felt confused when I starting a new C++ project, even though I already knew how to write C++ code. So be patient, we will get into actual GDExtension code soon. Also, if you like to support this video series, you can use YouTube thanks or support me on Patreon. This is the CMake file we have created in the last video. First, I want to add a new option that let us choose whether to include the debug tool or not. I use the set function and I create a variable called with debug tool. And by default, I set it to off. In CMake, a true boolean is usually represented by on and false is represented by off. Up to this point, we have created a normal CMake variable. To make it visible in the build option and store it in the CMake cache, we add the cache keyword. After that, we specify the type of the variable. In this case, it is bool. And then we provide a short description for it. For variable types, we have several options in CMake. You can use types like bool, string, pass, file pass, and internal, which is used for internal cache value that shouldn't be modified directly by user. Now, if I run CMake with -l, you can see with debug tool option is listed there. And we can also change its value. Alright, now that you know how to add build option, let's organize our project a little bit more. This is my approach with CMake. You might have a different method. I usually create all build option in the top level CMake file. For example, here I add with debug tool option in the top level CMake. Then I add another CMake file in the main source directory. In that file, I use the variable and option defined in the top level CMake to build my shared library. In CMake, if you define a variable in top level CMake file, it is visible in subdirectory CMake file. The reverse is not true. So in short, create variables and option in the top level CMake and then use them inside your source directory CMake file to build the shared library. So I copy all of this into the CMake list.txt inside the src folder. Now I need to make a few changes. First, I change globe recurse to globe because this time, depending on the build option, we don't always want to compile everything. I correct the path inside the file function. I also fix the path of the output library. Here, CMake source directory gives us the path of the top level CMake. Finally, I add this CMake file as a subdirectory in the top level CMake. Up to this point, if I run CMake again, everything should work like before. Okay, let's create a directory for debug tool. Inside this folder, I create a debug tool class. This class inherits from sub-viewport container. I use the notification function in this class, so when it receives the ready notification, it adds a label, and on the process notification, it updates the FPS counter label. Also, if the VS Code doesn't recognize your header at first, don't worry. After running CMake, it will be recognized. So this is the CPP file for the debug tool class. You can see that when it received the ready notification, it adds the label. And when it received the process notification, it updates the FPS counter. If you don't fully understand this code, don't worry. What is important in this video is learning how to control what gets compiled and what doesn't. In CMake, I use the file function to grab all the CPP file inside the debug folder and store them inside debug-src variable. Then I create a condition. If with debug tool variable is on, I append debug-src into my src with the list function. In short, this means the debug tool source file will only be compiled when the debug tool option is enabled. So here, to make sure everything is working, I just print my src. So for now, as you can see, the debug tool get compiled. Let's turn this option off. And as you can see, the debug tool not compiled anymore. Now we need to register this class. Basically, in register type.cpp file, we should include the debug tool header and register it like GDHello class. But here is the problem. How do we know if the debug tool is actually compiled? If we try to register it when it hasn't been compiled, we'll get a compile error. This is where C++ macro comes in. We can define a macro when with debug tool is on, and then use that macro to conditionally include and register the debug tool class. In my CMake file, I create a condition so that when with debug tool is on, I define a compile definition with the same name. Now in the register file, I can use this compile definition. At the top, I add a preprocessor if statement. When with debug tool is defined, it includes the debug tool header. Another thing to note is that VS Code can detect with debug tool is defined because we are using compile command.json. If in your case VS Code doesn't recognize the compile definition, make sure to run CMake and make first. Now I use the same concept to conditionally register the debug tool class. Here I use GDEregister internal class to register this class. The reason is that we don't use this directly in Godot editor or GDScript. It is only used internally by this GDExtension library. So we register it as an internal class. Okay, for now I use GDHello to add the debug tool to the Godot C. But you could also create a separate class specifically for adding internal class based on the compile options. Here I add a notification function, and in the CPP file, I include the debug tool header and some other header only if with debug tool is defined. Then I use this code to add the debug tool to the scene. You'll notice that I use a local static variable to ensure it's added only once, even if the function is called multiple times. I also wrap this code in the same condition, so it is only compiled if with debug tool is defined. Now you can see that if I turn the with debug tool option off, VS Code also detected and show this piece of the code as disabled. Okay, I activate it again, build the library, and then I run Godot. So here I am in Godot with GDHello added into my scene. So if I run this, you can see FPS counter is added here. Then if I disable this option and I compile this library again, you can see the FPS counter is gone. Okay, so this is working, but there is a better way to do this. The things that I don't like about this way of defining C++ macro is that the code isn't very readable. If someone new look at this code and sees with debug tool for the first time, they might not know where it is defined. They have to check the CMake file or documentation to check what is this and how this works. Ideally, I want to be able to click on this macro in my editor and see where it is defined, and maybe also read a C++ comment explaining it. So how we can do that? The solution is to define a macro in a central header file that is included in the project. In that header file, you can also add a comment explaining what this macro does. But sometimes we don't want to define this macro depending on the compile option. That is where CMake configure file can help us. This is how I can create a configure file. Inside my source folder, I create a file called gdhelloconfig.h.in. Note that we use .in extension for this file. This means it will serve as an input template for CMake to generate the final header file. So what we can do inside this config file? Inside this config file, we have access to all CMake variables. Let me show you an example. In my main CMake file, I create a variable that stores the project version like this. Now I want to add these version numbers as C++ macro inside my config file. I add them like this. You can see that I use the same pattern to reference CMake variable using the $sign and the curly braces, like in CMake. Now let's generate the config header file in CMake. In my CMake file, I use configure file function to do this. I also remove this compile definition because we are going to use a config file instead. The first argument is the path to the input config file. And the second argument is the path to the output file, which I put inside build include folder. Now if I run CMake, you will see that gdhelloconfig.h is created. And inside that, all the CMake variable is replaced. Of course, for the version string, I need to add quotation marks. Okay, let's add with debug tool macro in the configure input file. For that, we use a special keyword CMake defines, followed by the CMake variable name. CMake will automatically define the macro if the variable is on and leave it undefined if it is off. Here I can also add a comment to make it more readable. So if I run CMake, you can see with debug tool is defined. Now if I disable this option and run CMake again, you can see this macro is not defined. Okay, let's add the build include directory to the include path. I do this using include directories function. And finally, in my code, I can use this header to get all the macros I need. As you can see, if I click on with debug tool macro, VS Code shows exactly where it is defined. Okay, that was it about this video. Hope you like it. Until the next video, have a good time.